David Smith here with yet one more flipped classroom math lesson. 3 tips before we start. First, remember that you can slow down or speed up the playback to suit your needs. Second, you can pause the video at any point to catch up with your notes or jot down questions. Third, you can turn on the captions and read my words on the screen. Today's topic is going to be inverse variation. But before we start, I just want to give a shout out to my friend Furious for inspiring me to get my own Stetson. So Furious, this one goes out for you. Okay, let's take a look at variation. So to review, direct variation are two things that change in the same direction. Like for example, if you're working, if you work more hours, you get more pay. So pay varies directly with hours. Inverse variation is a different thing. It varies, the two things vary in different directions. So before we come up with some examples for that, let's just go over our notation. Here was our direct variation. We have y alpha x to the n. What this really means is that there's some constant times x to the n, which is going to give us y. So here we go, we put it into more of an algebraic expression, y equals k x to the n. So that's direct variation. Your k, if your k just increases this, so they're going to change together in the same direction. Now, indirect variation is a little bit different. Y varies as 1 over x to the n. So as this gets bigger, bottom part of a fraction, y is going to get smaller. So that's inverse variation. And what we can do is just write it more algebraically as y equals x to the n over k. Our constant, our thing that affects our variation. Okay, so I want you to pause the video and think for a minute. Come up with 1 or 2 things, situations in life where you have indirect variation. Okay, I came up with 3 examples. You probably came up with different ones, but let's just take a look at this. I want you to understand the fundamental relationship with inverse variation, okay? And it comes up in the world in quite a few places. So one of them would be if I drop a rock or I drop this pen, falling time versus height. The more time it falls, the less height it has. So as time increases, elevation above the floor or above the ocean or whatever height you're measuring is going to decrease. So these two things are going to vary inversely with each other. Here's another one. How about the number of students in a class and the empty seats? The more students I have, the fewer empty seats there are in the classroom. That's inverse variation. And finally, this last one would be, this is more of a school application. Hours awake, say for a day, versus test score. So in other words, if you are awake for 24 hours, that means you didn't get any sleep, chances are your test score is going to go down. So hours awake goes up, test score goes down. Okay, let's do a problem. This is a construction problem, and so the more people you have working, the less time it takes to get finished. So that's inverse variation. More people, less time. So let's take a look. The number of hours to construct a wall varies inversely with the number of people working on it, right? Okay, so here's our equations. This is our relationship that y is going to vary inversely with x. Notice how x is on the bottom of a fraction where our k is over here. So we can turn that into an equation for our situation. N is the number of hours, x is people. So the number of hours is going to be our constant divided by the number of people, okay? So here's a problem. They're giving you enough to solve it. A wall takes 2 people, 3 hours to build, okay? So now we know a couple values. And then the question is, how long will it take 4 people? So what I want you to do is pause the video right now and see if you can figure out how to do this one, okay? And I want you to do it algebraically by finding k first and then using that expression to find the answer to this one, okay? So pause the video and give that a shot. Okay, let's see how you did. When we know that it takes 2 people 3 hours to build, we can write this equation. 3 hours equals k over 2 people. Okay, so that is our equation now, and since we have one variable in an equation, we can solve it for k, and indeed this gives us k equals 6. So now we know that our expression is number of hours equals 6 divided by the number of people. Sweet. So now we can use this equation to answer this question, how long will it take 4 people? So now we don't know our hours, so n equals 6 divided by 4 people, that's our x value, which is 1.5 hours. Now I know there are probably some of you out there watching right now who said, I didn't need to do any equations with that. If it takes 2 people 3 hours, if we double the 2 to 4 people, it should take half the time, which makes 1.5 hours. And indeed, that's true. That's a very accurate way to think about this. However, you'll get problems where that kind of thinking might not work out so well. So you want to get used to first finding your k and then using your k to answer the question. Or in the next board, we're going to work the problem backwards. So now that we have our relationship, we've solved to find out how many hours it takes more people to build the wall. So now we can ask questions in a different way. So this one says, what if it took a half hour to build the wall? Okay, so we had a wall, we built it in half an hour. How many people did we need for that to happen? How many people worked on it? So I'm going to go ahead and use my function here. Number of hours is 6 over the number of people. This is the same example we did on the last board. So number of hours, we've got 1/2 equals 6 over x. Now when you cross multiply and solve for this one, you're going to get x equals 12 people. And that is your answer. Now that you've watched the video, jot down some notes or questions for our next class. You can also re-watch the portions of the video that you didn't understand so well the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.